Welcome everyone. I'm Kevin. I'm program chair for the Club of Puget Sound, and we're really excited to welcome MIT alum Karen Donoghue and her colleague Craig Newell from HumanLogic to talk about their new iPhone app called Local Haze, which lets anyone track their air quality readings from over 30,000 sensors across 6 continents. Karen founded and runs HumanLogic, a user experience consultancy with clients ranging from large corporations to early stage ventures. She previously worked as a designer at Microsoft and Motorola and completed her undergrad at Tufts in computer science before earning a master's at the MIT Media Lab. Karen has also been holding US expert office hours at MIT mentoring service and advising MIT VMS entrepreneurs there since 2011. Craig is the former architect for mobile at VMware and a principal at HumanLogic. He's also co-founded a VC-backed mobile device platform startup in Boston that was acquired by Sun Microsystems. And together, they've also co-authored a new book, Envision Product User Experience for Founders, to explain the principles of user-centered design applied to new product design in startup settings. Thanks so much for taking the time to speak with us, and we're really excited to have you. So we'll let you take it from here.
Great. Thank you so much, Kevin and Isabella and everyone at the MIT Club for Puget Sound. We're really excited to be here. We're going to talk about air quality as measured by something called particulate matter, or PM, you may have heard it called. We're going to talk about some work we're doing about monitoring by citizen scientists, and we'll do a case study on local haze. We'll talk a bit about the interaction design challenges at scale for monitoring air quality, and by scale I mean not only just scale in lots of entities across wide geography, but also in time and also quality of data. And then we'll also take Q&A. You can submit your questions into the chat, and then once we're through the slides, we'll start answering them, and we're happy to do that. So we're really happy to be here. We're going to answer some questions tonight. What does it mean to monitor air quality at scale? And some of the HCI, or human-computer interaction design challenges to enable a great experience for citizen scientists who want to monitor their air quality. And we'll also talk about, as we mentioned, scaling impacts in terms of designing these data-intensive products. So as Kevin mentioned, we're Karen and Craig. We've developed the Local Haze app, and we've got a practice called HumanLogic. It's a practice I started. And we've had both long careers in technology software, mostly software architecture, platform design, and product design, user experience. And we recently published a book, which is about user experience for founders. And as Kevin mentioned, I'm a Media Lab alum. I earned my master's there. Some of the companies we've helped in our practice range from really large companies to really, really small ones. So and sometimes very large projects, sometimes very short projects, but it's quite a range, often dealing with devices or connected devices, perhaps being managed at scale. And some of the devices that I've worked on are all the way on the left is the Savage mobile device platform, for which Craig was the chief architect and the co-founder. That was a full Java stack mobile platform. That is the Razr 2, which is was a Motorola phone. Worked on the UI framework. Interesting design challenge because there are 2 display screens, one on the inside as the phone is open, and then one on the back when the phone is in a closed position. The Misulu keyboard, this is an iPad, and then it plugs into the keyboard, making it a MIDI device. The Kodak wireless picture frame shown here. And this is a robot for stroke patients to help them with their rehabilitation, and at the same time help the therapists who treat them so that they don't suffer repetitive injuries. And on the right is Local Haze, which we're going to focus on tonight. So Local Haze, what does it do? It crowdsources air quality sensor readings over 6 continents, about 30,000, maybe 30,200, 300 sensors, and it rates the data from those sensors for accuracy. And you can see a kind of world map of where all the sensors are and how they appear in different countries. When we say at scale, what we're talking about is many thousands, hundreds of thousands, maybe millions of entities. And in this case, we're talking about air quality sensors, the things that actually monitor the air and report the data on air quality. So we'll take a look at what local haze looks like when you're running it. You launch it on your iPhone. You can look at your collection of sensors that are reporting data, and then you can look in detail at a particular sensor, or you can take a map view. You can look all over the world. You can zoom into a region, and this is California. You can look at the air quality at a different level of abstraction. You can tap on a sensor area, and then you can see all the sensors for that area, and then drill down and look in detail at a particular sensor. So that's a kind of overview of the user experience. Now, why is air quality monitoring important? And why is this product important? The reason is because air quality and its impact on health is in the news. You can see headlines here. There are plenty of headlines every day. Human health is affected by air quality, and pollution is really a health issue. And so, part of the reason for starting Local Haze was that I was given a prescription for an inhaler because I had an asthma diagnosis. And so Craig and I started thinking about what is in our air, what is in the air that we're breathing, how can we understand what it is and be more confident about the air we breathe. So we wanted to investigate, what does it mean to measure particulate matter? You'll hear it called PM. When particles are smaller than 2.5 micrometers in diameter, it really poses a risk to your health. It can get into your lungs, into your bloodstream. This is a great EPA diagram, excuse me, an EPA diagram where one PM 2.5 particle can fit 4 of them into this blue circle and then 20 of them in the width of a human hair. So that gives you an idea of the scale of these particles. And as I said, the smaller the particles, especially smaller than 2.5 micrometers, these are really fine particles and they can get deep into your lungs and even pass into your blood. Every country has a health impact index for particulate matter. So this is an example of the US EPA AQI, or Air Quality Index. It's categorized, 0 to 50 is good quality, 51 to 100 is moderate, and then it goes up from there. And it's sort of mapped into this 6-color scale. So we took this as a sort of starting point when we set out to design Local Haze. But the first, we're going to think about how do you actually measure the air quality?
So conventionally, it's been the role of governments in order to measure the air quality and to police it. So if we look at a conventional air quality monitoring station, these are very large, sometimes just a shipping container, but sometimes they are even larger than that, set of instruments that are set up, very costly, and obviously not easy to site in various parts of the world.
On the left are some air quality sensors off the coast of Toronto, on Toronto Island. They're very large. You can see them here, protected. And on the right, these are in Austin, Texas. So when we've been traveling around the world, we tend to take photos of the sensors because we're interested in where they're located and what the physical design looks like.
But they're all a $1 million plus sort of cost thing. And as we look at it, they're pretty expensive to operate as well as just to install.
This is the sensor in downtown Toronto. It's on the street, but you can see it's protected from anyone touching it.
Now, the key to this is, as well as just being expensive, is that they require regular maintenance. So they're not something that's just set and forget, but they're something that you have to actually actively go and maintain. So you're changing filters, you're cleaning things on sort of a monthly basis. And then on a quarterly basis, you're going in and calibrating because you're wanting a sort of a reference sensor. So you have to go in and sort of create fake clouds of dust and then go and make sure that the sensor is still correctly calibrated against that. So when we start to look at it and say, how would we measure air quality? So the reference way of doing this is what's called gravimetric measurement, or literally you just get a filter that you pump air through, you weigh it before you pump air through it, and then after you've pumped a certain volume of air through it, you weigh it again and you check the difference in weight. And that will basically give you the particulate matter grams per cubic meter of air. Obviously very accurate, but a little bit labor intensive if you're constantly having to take filters, pump air through it, and it's not a continuous process. So when people started to look at it and said, okay, we want to measure it continuously, then the way that obviously comes up is with regards to beta radiation. So beta radiation is nuclear radiation, which is very sensitive to solid matter, and basically is blocked at the smallest little particle of solid matter. So if you just take your airflow and you just pass it through a beta radiation, you can measure very accurately the number of particles in that. But of course, it is radiation, it comes from nuclear sources, so it's not particularly user-friendly to anyone in this day and age. So what smart people come up with is basically a microbalance. So here you can basically blow air with particles in it into a little spinning tube, and that spinning tube will vibrate at a different rate depending upon how many particles hit that particular spinning tube. And this sort of invention, if you wish, here allows you to continuously measure air quality and to do it in a relatively cost-effective way. Here we're talking tens of thousands to hundreds of thousands of dollars for a machine, but it's much less costly than having to have a human that comes in and is constantly weighing things. Now, obviously, with the invention of solid-state electronics, you can do even better from a MET way. So there are various particle counters now where you can shine a laser through some air, and you can actually count how many times that laser was interrupted, and you can measure how long it was interrupted for. And by doing that, you can get both a count of the individual particles in the air and a size distribution. And the size distribution is interesting because that can give you a hint as to what sort of pollution is in the air. Is it the diesel pollution? Is it cigarette smoke? Is it vaping? Each of those have their own interesting size distributions that you can sort of gather. And so these devices are just sort of starting to come to market in the sort of the hundreds of dollars sort of range for the sensor itself. And then finally, people have worked out that you can actually emulate what we all see as humans as haze. So if we look on a hazy day, there's particles in the air. You can't see them up close, but if you look at them on the horizon, you see that as a colored haze. And so you can do the same thing with a light source in an enclosed space, and you're measuring it with just simple scattering. And obviously the amount of scattering can give you sort of a little bit of an indication as to how big the particles are, but it's a little bit approximate because you don't really know the color of the particle and other factors. But the advantage of this is that these are cheap. These are like a $10 parts that you can get in mass quantities. So if we look at it, we have a whole range of different ways which we can measure particles in the air, from a very accurate and very slow method with gravimetric, all the way down to the light scattering, which gives you a much less accurate, but a very cheap way of being able to measure everything. So as these sensors have now become reasonably well and truly available and have gone through a couple generations, so they're not just an interesting science experiment, now you've got this range of all sorts of different people, from people like PurpleAir and URAD Monitor, which produce little tiny IoT devices, if you wish. So one of the little scattering light sensors with a little computer attached to it. You've got small names, you've got big names like Davis Instruments that we all know of for making weather stations and so on. You've got community groups, so Sensor.community. They're a European group that just puts together kits where you can get the little board and you have to load your own software onto it and you wire it up and you put it in a suitable enclosure and off you go. And then other people taking another direction. So Plume Labs, for example, instead of trying to measure your air quality at a particular place, okay, they're saying, well, what happens if you carried that sensor around with you and you basically got a dosage meter of air quality for the day? What have you experienced? And obviously it can record where that you've experienced that. So there's a huge range of these low-cost sensors which are starting to come to market.
One thing I want to note is on the PurpleAir sensor, you'll see here underneath the sensor, there are 2 lasers. That means that you have some redundancy in the data that's being reported. And we use that to understand how confident we can be in the data that's being reported by the device. So you'll see that later on when we look at the design.
So if we look at each of these low-cost devices, they're very simplistic. They may or may not even have any storage on board, and they basically just communicate via the cheapest communication mechanism with the internet, and that's pretty much always Wi-Fi. So these little devices are just hooked up to Wi-Fi, communicate across the internet, and then there's some big database that lives in the cloud where the measurements are stored. And then the clients that want to be able to access this so that you can view the data, they obviously access these same databases across the internet. So this is a very classic IoT system that people have put together. The communication is just pretty much always Wi-Fi. It's cheap, and it's always just HTTPS. So it's nothing fancy. It's all just a simplicity over efficiency or performance sort of things. We're dealing here with sensors that are reporting data anywhere from once every 30 seconds up to once every 5 minutes. So there's not a huge amount of traffic that comes with these devices. The actual clouds themselves, because it's sort of an open community of citizen scientist things, we have all sorts of different clouds that people put the data in. Some of them are run by device manufacturers, so PurpleAir and URAD Monitor run their own sort of sensor clouds. There's people like Sensor Community, which is sort of crowdsourced and run it as open. There's government. The US EPA runs a worldwide one called Air Now. And even people like the US Department of State are getting into the business. They have installed sensors at a majority of embassies worldwide, and they run their own little database of all of the air quality that they've measured at all of their embassies. So both small and large, all sorts of scattered different places that people are putting their data together once it comes up to the cloud.
So from a user experience design perspective, it is sort of interesting to think about combining the data from low-cost sensors. So for example, the PurpleAir sensors, the Sensor.Community DIY sensors, or the URAD Monitor sensors, the low-cost sensors, and then also now with the expensive sensors. So for a total of approximately 30,000 sensors that are being monitored, you have some percentage that are low quality data reporting and high quality. And it is a challenge because that's quite a large disparity in both the volume and the quality of the data. So you get lots of low quality data versus a very small amount of high quality data. And you have to think about what is the design of that experience in terms of communicating quality of the data, not just the value of the data. You can see there's 95% of the data is coming from low cost sensors, only 4.3% coming from high cost sensors. So it is a challenge in terms of designing the data reporting experience. So whenever you set out to design a new product or improve an existing one, you really have to focus on who is the user of your product. What are their needs? What are their pain points? And what we're doing with Local Haze is we're targeting consumers that are also citizen scientists. They don't have to be engineers. They don't have to be PhDs, but they have to have a couple of qualities. They have to have motivations to be interested in their air quality and understanding and reading the data associated with it. So this is an example of what we call a persona. It's a user model you use when you are setting out to design new products. You want to really understand for each of your unique personas. You may have multiple personas that are part of your target user population. you really want to understand as much as you can about their frustrations and pain points. So in the case of a citizen scientist, air quality enthusiast, we have someone who's concerned about local air quality and can't find that DIY sensor to buy. Maybe he's going to build it himself and has a family member with asthma. That's an example of, things that might drive their behavior to actually go and seek out solutions that might include what we're doing with local haze. They might be motivated because they're interested in the rise of low-cost sensors and they want to know like what kind of data do they report. And maybe they read some EPA scientific reports, maybe they don't understand everything in it, but they're curious enough to go in search of that kind of data. And they need it to be easy to use. Maybe they have a use case where they have an elderly parent who has a lung issue and they just want to know, can my elderly parent go for a walk? Or can my child go out to play soccer today if the air quality is good enough for that? At the same time, we look at brand affiliations and expectations and the typical workflows in work and life, and we want to design a solution that addresses these problems that users have in a way that's comfortable and makes them really happy and excited to use the product. So for example, focusing on the frustration and pain points, we really looked at the example where we heard over and over again that people are concerned about local air quality. They can't find a really good sensor, or they buy the sensor and they have to tinker with it, that don't know exactly how to put it on their network. And they really concerned about a health perspective. They have a family member with asthma. So from a design challenge point of view, there's presentation of the data, in the presentation layer, how do you present that data? And remember, if you're a scientist, you're expecting maybe an Excel spreadsheet versus a citizen scientist or non-scientist is expecting something that is easy to use and at a glance, like a dashboard that doesn't require a lot of cognitive load. They want it to be easy and glanceable. They're expecting a consumer quality experience. And in part because we've deployed on iPhone, there's an expectation because the underlying platform is so easy to use and places ease of use as its core. There's an expectation that the experience will be easy. In terms of the interaction, which is not the visual presentation, but actually how the user interacts with the application, we had to do a lot of work on mapping the data into a great user experience, not just for looking through collections of sensors, but also for interacting with geographic data when we introduce mapping. So there's an interesting blend of interaction models. And when you're doing mapping, especially, there's an expectation it'll be real time. We're using gesture, which is part of the native iOS interaction framework. It has to be performant. It has to not lag. It has to be real time. There's high expectation there. So in terms of scale, which is what we're talking about now, the scale is really the number of entities across geography. Remember, we said over 30,000 sensors. This was a reading from last week. It's actually a little bit lower today. It seems to go up and down depending on sensors that are coming on and offline, but it's about that number. And you have to step back and say, when you're designing a solution using that with that many entities that are being monitored, what user experiences work best for dealing with lots of things, in this case, sensors. So we started with infinite scrolling. That's one interaction. You can see it here. This is just listing out all the sensors. And this is a typical interaction model. You'll see it in like Twitter, etc. But we said, all right, that doesn't really work if you have a number of sensors above a certain level, like over 1,000. When we started, there were only 1,000 sensors, right? And then over time, we got more and more sensors added and began monitoring them. So we said, all right, let's help the user manage that infinite scrolling list by adding filtering. So you can see we added a new feature, filtering, keyword, and then it lets the user filter the list. And that made it easier for users to be able to find particular sensors, especially among thousands. And then as we grew into tens of thousands of sensors. After we did filtering, we said, okay, let's add something called relevancy, because people told us, well, I have a favorite sensor. I live in the Bay Area or I live in Toronto. I need to be able to pin that using the Pinterest model, by the way. I want to be able to pin that sensor to the top of my list so I don't have to always be looking for it. I just want it to be always there. So we added that feature after users told us they wanted that, so that they could pin that to the top of their screen. After that, we said, all right, let's tackle mapping, because users told us they wanted to see things on a map. It was very, very challenging. When we first started on the left, you could see what happened our early release, which was just putting the sensors on, and it really was a mess. Users complained. We actually weren't aware that there were so many sensors. You know, it's a real problem. And so what we had to do was we had to go back and come up with a set of heuristics, basically algorithms to do appropriate clustering to be able to show the visualization at the right level of abstraction. So for example, remember, it's a real-time map and you use gesture to be able to navigate it. So at any point, based on where you are zoomed, you want to show the appropriate level of view of how many sensors are in that region. And also we wanted to give users a bit of a hint about what the air quality is. So you can see we use this kind of ring approach. So you can see for the 1,508 sensors in San Francisco, vast majority of them are good, but there are some that are not so good and there's some that are really bad. But it was a real challenge. We had to really work hard to do multiple releases to get that behavior, user experience behavior, interaction, and the performance. Again, it's really about presentation at the right level of scale. So this is near New Delhi. You can see, you know, you get 12 sensors here. Now this area, the air is quite bad, right? And so you want the user to be able to, at a glance, know that at that level of scale for 12 sensors, that region, the air quality is poor. So this is Seattle. This is Seattle's air taken this afternoon. You can see here's an example of, you know, you sort of zoomed out to look at the broader Puget Sound area. And you can see a lot of sensors. There's a lot of people, both private citizens and probably also airports and embassies and other people who have sensors that are reporting the data, and it looks really good. I mean, down here near Auburn, there's a little bit of yellow, so maybe that's near the airport, something about the air quality there. And sometimes when we look at regions during the year, we'll see wildfires and other events that are having very, very negative effects on the air, and it's changing very, very rapidly. Today, Seattle and Puget Sound looks really good. This is actually the central district of Seattle. And then when you actually, I chose one of these sensors, this is the detail there. So you can see there's a natural kind of interaction between zooming in from the mapping view, choosing a particular region by pinching and zooming, the gesture, and then drill down into the details of the sensor. And remember when I was mentioning the PurpleAir sensor before, it has two lasers. That's because it's reporting the data in sort of a redundant form. So here you can see for the PurpleAir sensor, we're actually showing the different PM sizes, PM1, PM2.5, and PM10 that are being reported by the device. We're actually looking to see, we're trying to calculate, not just report the data, but calculate the confidence level. That's what this little badge is. And we look at patterns like, are the two lasers reporting similar or in the same zone data? If they don't, then that becomes suspect and it lowers the confidence rating. This is another example of what it means to do the mapping. Like this is zooming way, way out so that you're seeing both North America and South America. And then being able to, with one, you know, gesture, zoom into California so that you can see the air quality there. You can see around LA, the air quality is not so good. And then zooming into detail of LA, you can see that it really is a lot of variation, but it's very, very challenging, both in terms of getting the interaction right, the expectation on the user of performance, and the visualization at that level of scale, very challenging. So scale, when we talked about, you know, just now, is really geographic scale, but now we're going to talk about scale, another form of scale, which is scale in time, which we didn't really know when we set out to do this. We were going to have to deal with this. Users said to us, we want to know when there's changes in air quality at my particular location, or, you know, my parents are in Seattle. I'm in the Bay Area. I want to track my parents' air. I need to be able to know when that sensor changes. And so we said, all right, let's design this feature. Every sensor reports the AQI data according to a different cadence. So the PurpleAir sensors, for example, they report every 2 minutes. So that's a pretty fast cadence. Other sensors have different periodic intervals, maybe 24 hours or different time frame. So that was a challenge. And then on the right, I just want to show you what the visual language looks like. We wanted to be very clear in our design. We wanted a really at a glance, clean, modern design. We wanted it to actually be simple for someone who's not a technical person, but a citizen scientist to be able to say, oh, this air is good, this air not so good, this air is really bad. And at the same time, we wanted that confidence badge to have a kind of accuracy rating so that people could say, well, I see that I have a good rating, but it's a little bit suspect. So I have to make that a judgment when I'm deciding whether to let my elderly parent go outside for a walk today. So this was what the notification experience ended up being. We wanted it to be really simple. So here is the screen with the detail and sensor detail. And all the user does is tap the bell icon. That's it. Single tap. And now all of a sudden you're reporting the notifications for that particular sensor. Great, right? We were like, oh, we were so thrilled when we launched it. Well, what happened was the rate of change in some regions. So this is what's happening in, for example, Tahoe during the wildfires. You can see that the sensors are reporting data over and over again. It's coming very, very rapidly to the point where users started complaining. We did a beta with 10 users, most of them in the Bay Area, and they were really complaining. They said, this is too much data, it's too fast, I can't take it, you need to fix this. You can see here for Redwood Grove during a particular wildfire event, the sensors are throwing updates on the air quality almost every 2 minutes, sometimes every minute. And so we said, all right, we have to go back, and fix that, which is the great thing about doing app design is that it's never perfect. You're constantly having to improve, and you're constantly preparing for the next release where you're going to make adjustments or introduce new features. But we had to work on figuring out how to fix that oscillation back and forth across the boundary of an index reading, because that was causing problems in terms of the user experience. The scale and time was too fast. And it was really kind of touch and go there. It was almost like what I call the Goldilocks paradigm. This is too fast, this is too slow. I can't, we had to figure that out. And in order to get a really good, smooth cadence. We had 10 users in the beta release. They complained, and we worked on and are continuing to work on algorithms to smooth out that notification, and it's continually ongoing. It's never finished. So some of the questions in terms of design is, what's the right way to notify for a specific sensor? We're still trying to debate that. What does too frequent mean? And also, what does it mean for persistence? So should the notifications remain persistent on your notification curtain on your screen, or should they be ephemeral, which means they fade away over time? Those are two different sort of ways of approaching the design of these notifications. Again, it's something you have to think about when you're designing these kinds of, real-time data-intensive user experiences, particularly on a device. So we're going to cover some of the lessons that we've learned, especially if you're thinking about designing your own products or thinking about air quality work, which is very exciting for us. These are our lessons learned. You really want to understand the user's journey. Remember back to that persona framework that I showed you about the citizen scientist. You really need to understand who they are, their pain points, their motivations, the environment in which they expect to be able to use your product or service. This is a very simple, what's called journey map, which you use when you design a new product or service. And it's a visual timeline of your product from the point of view of a particular persona. We think of it as it's sort of the journey to value, right? So there's a kind of phases of the journey where the user first discovers your product. They might get a link, they might look at it on a search result. Then they might they might get exposed in some initial experience. They see your App Store entry. They make a decision whether they're going to download it, they launch it, they onboard it. Now, onboarding is often skipped in a lot of products that we work on in our client practice, but we wanted the onboarding to be really good because we wanted people to be confident in starting to use and engage with the product. The engagement means they're starting to use, look at sensors, browsing the list, drilling down into particular sensors and maybe favoriting them so that they get pinned to the top of the list. And then most recently, we've introduced a subscription service. So now users can purchase a subscription to look and see and subscribe to that notification service. And we have new features that will be coming out as part of that subscription. eventually, what we found, and we hope more of, is that people start evangelizing because they have a great experience with the product. They tell everybody, they share their sensor maps, they post their, they post their readings on Facebook or Twitter. But at the same time, we're watching the journey. We're also keeping very close track of the metrics of each stage of the journey. So for example, the number of installations, how many people get stuck on onboarding, how many people actually go through and use some of these features in the engagement phase, certainly some of the subscription metrics and other evangelism metrics. So you can see for onboarding, we had to really teach people, what does AQI mean? What is particulate matter, and why is it important? And you have to do this in a very sort of, think of it as a very small screen narrative, like a small film. And what we found was that originally in our first release, people did not understand the notion of the confidence rating, and they did not understand, how to read that sensor data in terms of understanding the confidence. We had to fix that. We actually have, we would say, ease of use, we maintain as a core attribute, and we get lots of requests all the time to add more and more and more data onto the screens, and we maintain that ease of use and kind of the clean design is a core part of our brand and our user experience. And so we recently were requested by more than a few users to add the AQI data onto the sensor list on the front of the first screen that you see in the app. And we did not want to do it. We wanted to keep the design very clean and have it just be, the reading plus the confidence rating and the name and the distance. And we decided that so many people were asking about it. We put it on, but we're using translucency to map the confidence of the data. So you can see that for less, for sensors with less confidence, where you have less confidence in the data, this is a faded look and feel. I kind of learned that at MIT when I was a graduate student. I was a student of Mira Cooper's in the Media Lab, and she used translucency a lot to indicate that information was perhaps not as accurate or important, and that is applied here in the design. People like it, and people are always asking us to even continue to add more data, but we're trying to maintain that same ease of use with that same branding look and feel. In terms of data access, we think keep it simple.
So when you actually look at the app itself, you don't want to have any logins on it. You don't want to have any sort of authentication. You just want it to work straight out of the box. And so what we've done here is we just follow that same principle. It's just a very simple HTTP access into the cloud to retrieve the data. We don't try and put anything, servers or anything in the middle. It's just straight in, grab the data and show it up to the end user. Obviously, when you do this, you have to realize that you're on a mobile device. So you have to look very much at the efficiency of the transfer, the cacheability, because people use the device and then they don't use it for a while and they come back to it and they expect to see things quickly. And then, of course, you're always checking the validity of the data. How old was the data that you got? Because it's one thing to cache it and be able to show it quickly to the user, which is great because the user gets that fast, immediate response. But on the other hand, that might be stale data. So you have to sort of balance the need for fastness with how often can you refresh it from the cloud.
Well, in terms of interaction models, I showed you examples where we have different interaction models. We have mapping, interaction, gesture, interaction. We have list scrolling. So really the advice is use the best interaction model based on your user's particular needs, and don't be so concerned about combining them in the same user experience. So Local Haze has a mapping interaction models, pinch and zoom, zoom all over the world, but it also uses list scrolling and filtering and pinning, which is what I showed earlier, and then drill down, which is when you actually, in a list, you tap and you're drilling into a sort of a lower level of the hierarchy of the graph, so to speak. And so, and also keep in mind, we think reporting on the data and being able to be transparent this is why we show all the data that we're reporting. We don't hide any of it. And we also, as Craig was mentioning about freshness, we are showing this timestamp because we want people to see the last time that sensor was read and whether they can actually say, well, it's that sensor data is, more than 15 minutes old. I'm not sure that I'm going to believe it. Also, we just advise is to solve for an applicable scale. Remember, we showed that there's scale in terms of the number of entities, over 30,000. We expect that number to keep growing, and we'll deal with the challenges that come with it as we do scale. There's the data quality. So remember, you have a range of quality coming from the sensors, and that is really interesting in terms of what does it mean to present that data so users understand it and trust it. And then you have this temporal issue where we had a real challenge when the data was coming in at such a fast rate that users said, we need this to be orchestrated in a more simpler and less rapid way. Also, in terms of designing this experience, I think it's important to understand what parts of the data impact the way the user perceives trustworthiness in the data. So in our case, we are reporting on the confidence, which is a sort of a technique we use, and then also the precision. So again, in the local haze, in the PurpleAir sensor, we're showing all the data, both laser readings, and we're also showing recency to show the freshness, and we're being very transparent. This is the source of the data, this is the location, and all of these things together, we think help to lead to a feeling of confidence and trustworthiness in the data. So putting it all together, this is the experience. Whoops, sorry. Putting it all together. Let me start that. So you can see here's the map navigation, real time. Performance keeps getting better with every release, but you can see this is moving in and zooming into a particular area of France, choosing an area with 6 sensors, drilling down into the details and seeing that sensor data. And it's been really well received. Local Haze maintains a 4.6 star out of 5 ratings. We get lots and lots of feedback, most of it really, really good. We get people asking for changes. We get all kinds of complaints too, but examples of people saying things like, I used it in Lake Tahoe during the fires. It really helped me understand the quality of the air. People have written in and said, I live in a recreational vehicle. I use your app to know where to go, where the good air is, especially during areas of wildfire. So it's kind of like a use case of a air quality compass. So that's very gratifying for us. We are seeing increases in lots of downloads during events like wildfires. So we expect that to start happening. Most years, the wildfires have started in August. We expect to maybe see that earlier. And it's free. Local Haze is free on the App Store. We would love your feedback. And now we'll take your questions. Thank you for joining us. Okay, so we're going to look at the questions in the chat. There's a question from Isabella. I'll read it out loud, or would you like me to read it? Okay. So with the increasingly poor air quality in the Pacific Northwest during the summer, do you see the focus on citizen scientists shifting towards a less technical generalist persona? That's an excellent question, and the answer is yes.
Yeah, I mean, you can see that obviously with the number of sensors that are starting to be deployed in these areas. So you're getting a very large number of them, and compared to the very small number of government sensors. And we're also seeing interest from people like the EPA trying to reverse themselves backwards because they realize that they don't have enough sensors, but that they want very high precision on it. So they're looking at it and saying, okay, can I take a few of the sensors that we have, which are high quality? Can I sort of use that to be able to calibrate all of these lower cost sensors in things? So even the US EPA and the government is trying to use these low cost sensors to better understand how smoke and things travels from fires, not just the citizen scientists, which are interested in it. And as we said, we're now starting to get a user base of people that don't actually have their own sensors, but rather just are using the app to navigate themselves around the conditions. And unfortunately, fire season has already started in New Mexico in the last few days, so it might not be that long before the rest of us experience the smoke.
Okay, I'm going to keep going with the questions. Thank you, Isabella, for that.